Your session is Secure Because Math, and your speaker is Alex. Thank you.
Thank you, guys. Okay, this is all right. This is working. Awesome. So thank you very much for being here. This is quite a turnout, to be honest. By the way, if any of you guys are from the internet and you like to do the Twitters, there's actually a hashtag for the talk because I want to make sure I laugh of all the jokes that you make out of my expense while I'm doing this. So please try to tag me or try to tag the talk or something like that. I just want to make sure I get to laugh of you guys as well. Anyway, so let's get started. My name is Alex, right? I am a self-appointed data scientist at MLSec Project. Been doing this machine learning thing for a while, not too much, but enough to, I don't know, maybe get accepted here. I have no idea what they're doing. So, machine learning researcher and trainer. I just want to let you guys know that machine learning training is nothing like Pokemon training. It was very different. It was not what they promised me at all. But I try to apply this machine learning stuff in network security and incident response. I was severely tortured by SIEMs. I do not want to touch one again in my life. I want to make sure that everything is done automatically for me, and that's pretty much my life goal for now. And if for some reason you want to do some sort of APT attribution on me, my hacker spirit animal is caffeinated capybara. Capybara is the official animal for the south and southeast of Brazil, okay? So let's get started. I want to make sure that we cover some ground here. There's a lot to talk. I think we're going to be good for time. First of all, I want to talk about the security singularity that is approaching, given all the machine learning stuff that's being launched on the following weeks. So we must be prepared for that. And, but also I want to get some history going on and to give you guys some perspective on exactly what has been done so far and what potentially is being done now. Of course, I don't have all the answers. A lot of this is my opinion and my research based on the stuff that I have done. So I'm happy to have any vendors come here and punch me in the face or anything if I say something that's very wrong. That's where I'm actually encouraging you to. But I want to make sure you guys get the idea of what the marketing looks like and what does the actual technical stuff around this looks like, so that we might go as far as put together some sort of buyer guide. So if someone is approaching you talking about machine learning, what questions should you ask them to make sure that they're actually doing some sort of machine learning? But anyway, I also want to thank you all for taking the time. I mean, you guys are all on vacation, right? I mean, we don't have to do anything anymore because of the amount of machine learning that we already have. I'm pretty sure that if network security is solved. And funnily enough, I think some of you saw this actual, I don't know if it was an advertisement, I don't know if it was on the website. This specific company doesn't do anything about machine learning, so I don't know, maybe the machine learning is in the wrong track. There's other ways to solve network security. But anyway, thanks a lot for taking some time out on your vacation. A side note that I wanted to give just before I continue this is that if you actually search for network security solved on Google, the first hit is Jack Daniel. Talk about branding, man. I'll tell you, someday I'm going to be the first hit on Google for that. But anyway, let's get back to the talk. The point is, there's a lot of confusion, right? And these are some questions that I've heard as I started telling people that I was doing this talk. They were, okay, but what about this? What about that? Is this a part of that? Is that a part of this? How does big data go into all of this? And all those questions that we face from time to time around this. And it makes it really challenging because the actual wording and the actual way that those things are presented to the general public, it almost seems like people are trying to deliberately confuse you. I mean, God forbid. Also, if someone wants like cool machine learning and big data pictures, there's this evil thing here, I have no idea, from bigdatapics.tumblr. Got a bunch of them, got like a digital wave. You guys can have so much fun. But I guess, are we even trying to communicate? I mean, what the hell is a hyperdimensional security analytic, right? What is the third generation artificial intelligence? Is that like the third level of the matrix, right? Is that where we are right now? I mean, and the security because math was actually used somewhere. I either dreamt it, or I actually read it somewhere. I don't remember anymore who was responsible for it. But I guess the point is that, again, I guess marketing people are going to market, but the problem is the way that those things are presented. It clearly hurts the capability of of buyers and even of investors, right, to differentiate amongst the offerings. We have no idea what these people are doing. We only know that it's mathy and it's advanced, right? And I'm guilty of that sometimes as well, right? Especially when I don't want to really explain what I'm doing. But I don't know, maybe I can do that because I'm like not a huge company with a huge marketing team, but that's not the point. The point is, I think it's important that people, the population in general that's actually going to be consuming this, and this is not like a fad, you know, and just like big data is not a fad. This kind of tool, this kind of thing is going to be progressively more prevalent in the tools that we have to use. So we kind of have to be prepared. And it was actually brought to my attention that it could be a communication issue in the sense that the actual technical people, they talk about what their technical things are doing, but then the marketing people are kind of unable to translate that. No, that's too complicated. Let's just use advanced or something like that. And that's fine, right? I just want to make sure that whomever is actually doing the work, you guys can get the chance to get to the technical guys and ask the questions that we really need. But before we get to that, let's do play a game. So here are three marketing, I'd say, lines of three different products who are, I don't know, doing mathy stuff. Can you guys guess what year those things are from? I'll give you a hint. They're not from the same year. Each one is a different year. Anyone want to try, I don't know, 20 years ago, 10 years ago? What you guys want to? Yes, there is one from there's one from 95, right? The bottom one, which maintains historical profiles of usage per user, is from 95. Right? It was one of the, I'll get to that, but it was one of the first IDSs that came out of academia, right? The first one, and I was hoping there would be some hardcore ISS guys here. It's actually from the Proventia anomaly detection. You guys remember that? That was like 10 years ago. And the middle one is recent. It's from this year. I'm not going to tell the company because I don't really have to, but I mean, it's hard to tell them apart. It's have we actually been doing the same thing over and over again? Well, I'm not sure, right? But there's this lady, Dorothy Denning. She was responsible for the first research that came out, what would become the first IDS, right? It was 86. And when she wrote the paper, she already had it there that, okay, this thing to actually work has to have a kind of a rule-based engine, right? Like a signature kind of thing. I'm not quite sure what that is, but you gotta like tell, okay, this is bad, so get that. But also had to have some sort of statistical package, some sort of anomaly detection built in that would be able to find unknown unknowns or anything. I don't think they used that word back then, but try to find some sort of AP that they definitely didn't do it. What's funny is that a few years later, her colleagues, I guess all men, decided to release the next generation IDES, right? You guys think you're fancy because all your stuff is next generation. Man, it's so 93, I'm sorry. And, but anyway, things changed when a three-letter acronym actually made a big fuss in the security industry. And it's definitely not the three-letter acronym that you think it is. Actually, some guys call it the KDD. What actually happened is, after Bro and Snort came out, DARPA pretty much figured out, you know what, I think we got the signature thing covered, let's do something else. And boy, were they right. This is exactly what we use today. But anyway, I'm not implying that they're bad. They do their job very well. But so DARPA released some data sets for user anomaly detection in 98 and 99, right? And it's, God, it's the crazy stuff. It's like some TCP dumps and Solaris audit logs. It's like, okay. And we have the KDD 99 data set, which is, I'd say by rights the most famous one that's actually used for some sort of machine learning or anomaly detection and security. It has over 6,300 citations on Google Scholar. And that's awesome, because the fact is that in '99, if you guys do actually look it up, look at the number of papers on the subject, there was a boom. People started publishing a lot using this data set, and they really started digging in what could we potentially find, having a minimal amount of information, what we could potentially dig around, right? And maybe we could take a little bit of the burden of us as network engineers or security people or whatever we were called back then. What bothers me is that in 2014, there's still like 300 citations. I mean, these people are using a 15-year-old data set to argue that their machine learning technique is better, is 0.5% better than the one that came out last year. And I don't know, I mean, there's a modified mutual information feature. I have no idea what that is, but why are you doing it on KDD 99? I'm pretty sure there are other data sets out there. Maybe, I mean, of course there are some things about publications, and I'll get to that, but this should offend you, right? In the same sense that if you were a med student and you're trying to learn anatomy, all that you had to guide yourself was this Rembrandt painting. And then you're like, hey, professor, why don't we cut up another guy? No, you can't do that. The IRB will not let you. There's some privacy issues going on. And I mean, of course, the human body hasn't changed that much, although I don't think we have a good, clear view here. But I think in 15 years, we kind of have evolved, and things have changed, and we should be trying to bring academia, in a way, in this public research to a higher level. With different data sets and things of the like. There's an interesting side here, is that back in 2000, there was this guy, John McHugh from Carnegie Mellon, who actually published a paper saying that the DARPA data sets sucked and that they were not fit for purpose at all. And I couldn't find one about the KDD 99, but maybe I didn't look too hard. But actually, it's an interesting paper. It's more of a rant about how people are not creating reproducible research, and frankly, that could have been written yesterday, but it's interesting because, yeah, people are misusing this, they're not publishing their methods, they're not doing this properly, they're just like, it's almost like a race to the bottom, actually to the top, where, okay, I got it like 1 percentage point better false positive prevention than you. And I don't know why I honestly don't know why there are so many papers. I was never a grad student. I never studied this in university. And maybe it's like a prank. Maybe it's like, if you do this, if you start researching this, you actually have to write a paper on KDD 99, right? That's the kind of the thing that you have to do. And, but anyway, I'm not trying to bash here, right? And there's a lot of work, but I just want you guys to get around the mind frame, right, of what usually happens when you're trying to do research on machine learning and things like that, when you have a very, very closed environment, and you're not trying to reach out and trying to understand what's actually there, right? I would never mess with academia. They are very scary, right? I mean, there was recently this math lab bust. I don't want to mess with these guys at all. But anyway, think about this, right? You're a grad student, right? You're brilliant, you're doing a great job, your professors love you, and you got this kick-ass result on KDD 99, and you know what? I'm gonna start a startup, right? I'm gonna get a business guy, and we're gonna start like building some shit. We're gonna like sell a lot of stuff, right? So I'd like to borrow the Gartner hype cycle here, just to try to illustrate what I believe is a probable outcome of that, right? Pretty much we start, hey, guys just started out, he has no idea what's going on, he's like, okay, where's the party? But then he starts studying, he starts learning, and he comes across KDD 99, and then, oh my God, the results are amazing. Like, I'm like 95% catch rate. It's like, it's fantastic. Let's put some money, let's get some mad VC money, let's do a bunch of stuff, right? And then they actually reach what would be maybe a production level data set, something that they actually gathered from a potential customer or something like that. And then you see that the inflection changes a little bit, right? Where are those results, right? Where is this thing that I'm looking for, right? And this is really where the road forks, right? It really depends on how able and how capable the business guys are. Because, I mean, you could just, okay, math, just stop. And that has two ways of looking at that. It's either the guy telling math to stop, or maybe the business guy is, okay, let's stop with this math stuff, because we can probably make money somewhere else, right? And we finally end up with, math is hard, let's go shopping. But actually, when I say shopping, I mean selling, right? So let's say, for instance, you've done a bunch of publicity around models that you build for specific purposes and that you are solving security, and then suddenly you transition your company to sell consultancy and instant response. There's loads of money on that. There's nothing to be ashamed of. And I mean, honestly, it happens, right? Maybe you didn't get the results that you wanted, maybe, and then you're just like, yeah, let's sell normal stuff. And I completely understand that. I call these guys the has-beens, which is unfair, because they're like swimming in cash, like, and I had to think this morning if I was going to pay for the bottle of water in my room, right? So, but the point is, hey guys, you already got yours. Leave some of the machine learning stuff for us. Like, there's some guys who are actually trying to do something. And there's another interesting pattern which I call the machine learning shrug, which is, hey, this sounds cool, let's put it on our brochure. I have absolutely nothing to do with machine learning at all. And you can realize I deliver lemons by bicycle using machine learning, something like that. You can usually identify by patterns like this, and they just add it to the brochure, right? And those two guys, they should be relatively easy for you to differentiate. I'm really focused on the sweet spot. The people who are actually trying to do something, they're actually trying to build anomaly detection engines, they're actually trying to build classification engines, right? And I want to talk a little bit about the technology, so that you guys understand. At least I can share with you what are the challenges that I see, right? And if these guys are really committed on doing a good job, this is probably some of the stuff that they should be thinking of as well, right? And this is definitely the stuff that you should be thinking of as well as you are shopping for potentially getting a tool like this to your environment. Anyway, let's start off with anomaly detection, right? Anomaly detection is interesting in the sense that it's mainly what we call an unsupervised machine learning problem. I'm not going to go, I mean, I already did a talk of like, yeah, this is this. I'm not going to waste too much time on that. But mainly, I guess what's important here is that when you're doing anomaly detection, you absolutely have no idea what's going on. So you cannot describe in any meaningful way what you're looking for. You're just trying to look stuff that it's weird. And weird in relation to something that's normal. So the pauses, the dramatic pauses are intentional. And, but anyway, this is not that bad. This works great, right? When you have an industrial-like process, right? When you know that your screw has to be like this tall, right? Has to be this wide, right? And you have this production line, and you want to make sure that you do not have defective pieces, right? That diverge too much from what would be expected. That's what anomaly detection is for, right? You have a very good grasp of what normal is. Since you have no idea what weird is, you might as well have a very good grasp on what normal is. Right, and this whole, you probably have heard of the Six Sigma kind of thing. It's exactly that. People are talking about, I'm trying to see something, I'm trying to make sure that there's no significant deviation until in a range of 6 standard deviations of the normal or the mean or what we'll be looking for. And this has historically been used in fraud prevention because, come on, your balance is a number, right? The money comes in, money comes out. The only operation you have is spend money. You can spend negative money if you're depositing or something like that. So in the beginning, people were were playing around with that and help. And still to this day, if you want to spend like $10,000 on casino chips here, your credit card company will call you. I mean, maybe not all of you. There's probably some, anyway. But you guys get what I mean, right? It actually works, right? And it's not just for. I'm not talking just about industrial stuff, right? If you are a DevOpsy kind of guy, right? If you are running an industrial-like internet process, right? When all your machines have to have a certain behavior, all your machines have to work in a certain way. These kinds of techniques, these kinds of behaviors are important for you to actually make a move to actually, okay, you see, there's red dots there. It's magically figuring out, based on past performance, that those red dots are weird and that potentially someone should do something with it. The problem that I find is that, of course, there are several problems, right? There's actually 3 problems that I want to talk about. And it makes it challenging when we're talking. Some of these are not security specific, right? But there are some of them who make it specifically hard for security, in my opinion. So anyway, in this mode, I'm generally speaking about network behavior analysis or NetFlow behavior analysis and user behavior analysis. I'll mostly be focused on network, and then we'll have a quick sum up about user. First of all, I want to talk about what is called the curse of dimensionality, which is a very ominous name for something that's actually very interesting. The point is, if you're measuring anomalies in something, you have to have a way to represent those events or something in some sort of space. There has to be some sort of dimension, something that you're doing, right? And you need to have a distance. So let's say that all your normal stuff happen here in this 3D space. How can I measure if this is an anomaly, right? So I can maybe try to put like an Euclidean distance here. So it's pretty much a straight line there. I can try to put, sorry? Okay, it was just feedback, I'm sorry. Or you can try to do a Manhattan distance, and which pretty much is you just walk like in Manhattan, like through the blocks. That's a terrible name, but anyway, it's not my point. What happens in high-dimensional data? And I will not go through the math. Actually, if you look at the white paper, I do have a link of a very good explanation that actually proves it with equations and such, if you are so inclined. But the point is, if you get like a lot of dimensions, I'm talking like hundreds of thousands of the different dimensions that you're working with, kind of all the distances look the same. And it's kind of hard to imagine because, I don't know, I assume that the policy is that there's no mind-altering drugs in Black Hat. But the point is, all the distances in this higher dimensional space, they actually end up being pretty much the same on average. It's very hard to tell things apart. Everything looks kind of the same because the space is so big, like, and that everything is so far away from each other, actually doesn't really matter anymore if you're trying to measure stuff like that, right? And a way of understanding that is that if you actually try to calculate what's the volume of a sphere in this space, in this multi-evil dimensional space, against what the cube looks like, right? You'll see that the volume of the sphere goes to 0 very, very quickly, right? And everything seems too far away, and you can't really measure like a unit distance very easily. So I'm going to try to show a practical example, right? So let's say you have a bunch of cats and dogs in a multi-dimensional space, like, and you're trying to draw distances between cats and dogs, right? And anyway, as you grow up the dimensions and you see that evil multi-dimensional cube there, I think it's supposed to represent like 8 dimensions. You see all the cats and dogs are very lonely and they're very far away from the center and they can't really talk to each other. But anyway, let's try a more practical example. What if I'm trying to do some NetFlow analysis with a company that has about n nodes, right? And what I'm trying to measure is how is their change on the ways that the machines are talking, or these nodes are talking to each other on the network, right? Let's say that I'll have like 2 times n to the power of 2 minus n possible connections between those machines, right? And then I will be actually considering all the ports and considering, of course, choosing a port for each one of them, and of course the direction of the communication. So with 1,000 nodes, which is a very, very tiny corporation, I'd say, it's 500 billion possible dimensions there. And of course, it's a very sparse matrix, and not everyone talks to everyone, and all those things. But you can just think that you're going to throw anomaly detection on a higher dimensional problem, and it's just going to figure itself out, right? You really have to do some different things. And this has been a subject of research for many, 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 many years, right? To actually break this curse, right? So there are some ideas. There are actually some companies I've seen who actually come forward with a very problem-solving orientation around this, where they have different metrics, or they're doing something on a sub-manifold or something like that. The manifold is a scary word, but just think about it's just like the Earth. The Earth is round, like it's a sphere, but for us, where we are locally, it seems like it's flat. We can draw an Euclidean thing here, although it wouldn't be an Euclidean space if we were only on 2D. That's pretty much what you have to think. If you're so inclined, think about warp drives, Star Trek, that's also a good analogy, but I'll stick with the Earth for now. And there's a lot of different techniques, right? And my point is, and there are a few interesting results. And I say interesting as in I cannot understand the abstract of what's written on the paper. It's way, way over my head. But the point that I'm trying to make here is that this is an open problem in machine learning in mathematics. It's someone who claims to have solved this, I mean, might as well be a trillionaire in ad networks, because I mean, all the smart people in machine learning are actually making money in ad networks. But or they could be literally curing cancer with this kind of things, right? There's actually it's called Project Baseline that Google just launched recently, where they're actually going to try to data mine the genome for a bunch of people, and they're going to see if they can find some anomalies there that maybe can point to some clues of what we should be looking at. So a funny story is that actually I was using this curing cancer example, and there was someone who actually reached out to me and told me that, oh, you should see the medical applications of our research. And I said, well, that sounds like awesome, right? I just don't want to be sick wherever you are, that company is working. But the point is, this is a complicated subject. Look into it. I mean, if you're really inclined and someone is, I'm doing anomaly detection and I've broken the curse of dimensionality, you should check twice, right? This is a very, very bold claim. And some people may have get some limited results that actually make some of these things feasible, right? I just don't want you to fall prey to this guy, right? It's like there's this weird trick that I'm doing that makes everything solvable. Just be careful, right? Just make sure that people are not trying to constantly blind you with math. Oh, I really like the one with the helmet. It's awesome. Anyway, but that's just one problem, right? I want to talk about normality poisoning attacks. And this is actually, I have seen more than one people discuss this when they were talking about big data analytics and things like that. And again, I go back to the story about normality, right? So what is normal, right? What is my ground truth, right? What am I trying to prove that's bad? What am I trying to prove that's good? And if you don't have a good grasp of that, right? And this is going to sound like every single person who ever challenged an anomaly detection product. I mean, I probably said that sentence in like 2004 when I was, I don't know, doing IPS integration. But I would say, yeah, but what if your malicious traffic is hiding inside your normal traffic, right? And it sounds like it's just nitpicking. But the fact is, in anomaly detection in general, specifically in our field, the number of the kind of stuff that looks like normal is actually, there's a lot more normal than anomalies, right? I mean, of course, let's hope that's not that is the case for your company, but there's infinite more machines inside your network that are not infected by malware than there are. Or at least that should be the norm, right? The fact is nobody really knows, and you're just having this thing there. And I really believe that if these things actually catch on and people start using more anomaly detection, we will see a lot of adversarial work around this, and that people will actively try to break this and actively try to make their traffic look more like what's normal, right? I have this example. I don't know if you guys know Waze. It was bought by Google recently. So it's kind of a crowdsourced thing where it gets input from users in order to tell you if the traffic is going well and while you're driving or not. The point is, I mean, I have a few friends that they're like, okay, I'm about to leave work, so I'm going to put like a lot of accidents around my building so that the traffic clears and then I can leave and go away, right? Okay, this is silly, but this is the kind of stuff that I'm talking about, right? You have no way of figuring that out. You have no way of filtering that. And finally, my favorite, Hanlon's razor, right? And again, this is one of the problems of you not exactly knowing what you're looking for. And it sounds funny, but this is actually a huge cause of people trying to use anomaly detection-like products and then just shutting the hell damn thing off because there's like too much stuff going on, too many alerts, too many things. And when they actually, most of them should potentially be handled by the operations team, the DevOps team, like I was talking before. And then if something, okay, this is really weird, I mean, we do not understand as the people who own this system, maybe we should involve the actual security team. But that's hard, right? It's much harder to design a process like that and try to advise people a process like that than actually just selling a box or something like that. I mean, I just want you to think of this, right, while you are evaluating this kind of things. Who is most likely to have done something bad? Is it the evil hacker or is it the hipster hacker, right? The guy who is coding Node.js, you know, and wanted to get closer to the metal on your production stuff. And yeah, the guy just broke your stuff. I mean, just pushed the wrong commit. And I really thank Matt for taking the picture. I owe him a beverage of his choice. Anyway, what about user behavior? It kind of works. It's actually awesome, but it works for specific implementations of specific solutions, right? When you're talking about user behavior anomaly detection, you're talking about fraud detection, product fraud detection. You have something that you know very well how it works, has a very limited scope. Someone has actually gone through the trouble of documenting the whole thing, right? And they can actually analyze and create what should be the ideal features, what should be the ideal way that this kinds of things should work. So there's some good examples from Square, from Airbnb recently, where they were describing how they were getting feedback from the systems and pushing it forward to create a machine learning model. Granted, it was classification, it was a supervised model, but it's very interesting. The question that I have, and this is an open question for me as well, right? Can it be general enough? Can we create like a general user behavioral analogy? And I've seen stuff like file exfiltration, right? But it all sounds like, I mean, okay, we will do machine learning to prevent your files from being exfiltered, but you have to make sure that you have clearly documented and implemented all the roles, and that you have a very clear information classification policy in your company and you feed that to the system. If I have that, I do not need machine learning. And I mean, it doesn't, to be fair, like most of the guys most of the companies that are around, have some sort of information like this, they will usually be from people that were from the intelligence community. They were from the government. Well, that's all a given. That's awesome, right? It probably works there very well because they will have very definite roles. They will have very definite information classification. But that's not how the enterprise world works, and probably never will. So anyway, also just a side note, has nothing to do with this talk, right? If you are like XNSA or something like that, don't tell them that you have like something to prevent your files from being stolen, right? It doesn't look good, right? It's not the best branding that you can go for. But anyway, if it's not files, then if it's systems, right? Can I average out user behavior? So it's like, oh, from different systems, I have some different profiles that somehow I was able to automatically extract the way that these applications work to create some sort of fraud detection profile. Can I just average them out? I mean, if I'm like, I don't know, going crazy on the expense report, right? Because I just went to Vegas and like had way too many drinks. Is this going to count badly on my user behavior? So then when I go to the work file, it's going to trigger me? How does that work? How do you talk about user behavior in general? I don't know that. I don't have enough information. But you should be asking people that. If people are selling you user behavior, you should, okay, what does that mean? How does that work? Anyway, it's like getting very late. Anyway, I just want to talk about classification real quickly, and this is an old slide. The point about classification is that I actually know what I'm trying to classify. So I'm aware that I'm trying to tell dogs and cats apart. And I might have a bunch of samples of cats, or maybe just that one, and I might have a bunch of samples of dogs, or maybe just that one, right? And again, I'm talking about the ground truth stuff, right? Because if you don't have enough ground truth, or you cannot express whatever the dogs and cats are, right? I mean, you're gonna miss some easy stuff like this happy cat, right? There are no happy cats. I have all the cats in my data set, and they're all grumpy. No, there are happy cats. You were just like ignoring them, right? The same way, not all dogs are as majestic, as thoughtful as Doge, right? You get stuff like this. So it's challenging. You gotta constantly be asking yourselves if whatever you're doing to train is actually representative of the ground truth that you have. But anyway, I'm much more, I like classification much more, right? And there's been a lot of malware activity researching malware, and I put that there on purpose. Classification, clustering of malware samples, and it's all very exciting because there actually has been a lot of data sets that have been published, and people have been trying to make this happen and try to, and honestly, from what I've seen, stuff that try to actually cluster malware, what I'm trying to say is that I already know that this is a malware. I want to know what kind it is, what kind of lineage it's coming from, where did the code base evolve from. These have been much more promising. These have been actually getting interesting results than actually, okay, I'm detecting malware here. And the reason why I say that is that my guess is that if someone is kicking ass on this and is actually doing the work, it's AV companies. They've had all this data set for ages, and they have had big data actual stuff to use them and to analyze them for ages, right? So, I mean, we're bashing them. They're probably on the front end of this. So, but what concerns me, because I never turn on the heuristics on the AV because it's crap. It always crashes my machine. I mean, can we do better than AV and heuristics, right? And again, this is an open question. This is something that people should be trying to, if you're approached by someone like this, okay, how are you better than this, right? Because there is a lot of data, but there's a lot of research that's crappy. There's a lot of research where you're putting evil malware stuff against, I don't know, calc.xe, right? And that's going to be a great, I mean, it's going to get a great, like, low false positive rate or anything like that, if that's what you're comparing it against, right? So, again, you got to be mindful of the ground truths. You got to be mindful how are these people training this model? How are these people doing this? I mean, if I had something, right, that could potentially download and run code from the internet, right, access the file system, access the camera, access location information, send it to remote servers, right? What would potentially I try to compare it to, right? I mean, it's like we got a bunch of these. And, but hey, I just had an idea. Maybe the difference between the average browser and a malware is actually that browsers have sandboxes. Oh, damn you, Firefox, we almost had it. Sorry guys, this is not the time that we have solved this. But it looks like I'm being very critical, but the point is that everyone makes mistakes, right? There was this guy last year, he was talking about this model that he built, and he was like, hey, I used Alexa for my good stuff, for the things that are not malicious. And that's lame, because Alexa is a very bad measure of this. I mean, honestly, we do have, there are very, if you're doing work with IP addresses and domain names, there are very few interesting measures or sources for goodness, right? There are some people who are helping out of that. OpenDNS recently released, they're calling it the random domains data feed, where they actually have their own version of Alexa, like 10,000 top or something. And they just go like, okay, these are 10,000 guys that we think they're not malicious. Some of them might be, like, but then have you guys ever looked at Alexa? But that's interesting. I mean, if you guys, if some of you like are interested in this and want to try this out, it's a good resource for you to look at. But anyway, how's it going then, right? Because that guy obviously had no idea what he was talking about. And what I have been trying to do, right? And this is for 1,000 failed experiments, this seems to be one that is actually looking promising, right? Is a private beta of our models that are based out of threat intelligence. And the actual ground truth is coming from stuff that I know that has been painstakingly researched from other people. But there's not enough of these people. And potentially we can use the markers and we can use the information that they have researched in order to expand our knowledge, right? The same way that if you are like a huge corporation, if you are an MSSP or something like that, and you get these feeds and you don't like use them as block lists. I mean, there's nothing intrinsically wrong with that. I have actually another talk that I talk a lot more about threat intelligence. But ideally, you should have a team who is analyzing this and learning from this stuff and doing these patterns, right? And this is pretty much what I'm trying to build, which is a model that will be able to learn in the same way as an analyst would learn and search for the same information that an analyst searches, right? When they're doing their investigation to see what's bad, see what's good. Yeah. But anyway, why should you care, right? The point is, it's kind of effective for triage, right? If you've got a bunch of log files that you're not looking, you're not doing anything at all, it's a great first triage to get like a list of 10 things that you should investigate on the following day as a part of the routine of the security people there, right? Just send some logs, right? And don't worry, it's only metadata, right? We're not interested in the actual content for now. And you get you receive a report with a list of potential compromised machines. I mean, you might want to download the feeds and do it yourself. Of course, I mean, we have some open source tools some tools that we open sourced yesterday on the other talk I was doing, where you can easily, it's a Python program, harvest these feeds from the internet, create some lists for them that you could potentially export to several different things. Only CSV and the stuff that we actually needed for the presentation is ready now, but we're committed to working on it. And there's actually the TIQ test, which is trying to do statistical analysis on the threat intelligence feeds and see how do they compare against each other. And is this new feed that I bought actually bringing me value or not? You could do all of that, or you could just have someone who's trying at least to do the work for you. But anyway, what about the ground truth, right? I've been talking so much about the ground truth. What are you doing, Alex? What's this ground truth look like? Well, there are a huge amount of threat intelligence feeds now, both open and commercial, right? And we've been painstakingly trying to figure out which ones are the best fit for what we're trying to do. And some of that is distilled on the tools that I told you. And, but no malicious samples are still very challenging, right? And we tried different things like very high-ranked Alexa, Quanticast, the OpenDNS stuff. But we actually devised some techniques where we can infer what an actual customer finds to be good or not, finds to be non-malicious or not. Basically, and then now I'm going a little bit on the anomaly detection side of things, but I'm actually just using it to seed something and making this model not so much entirely supervised, but a little bit semi-supervised. I don't really know what these things are, but I have a high inkling that these are positive. And that actually helps with the bias a lot. So if you have a company that's not your average US company that goes to the sites that are on an Axa and Quanticast, you see that their popular sites are very, very different. And it helps even out these unknowns when you're hunting for false positives. Anyway, but what about the data tampering thing that you were talking about, Alex? Well, most of the features that we use are actually derived from structural data and intrinsic data from the internet. Stuff like GYP, the ASN, where it's coming from, a lot of passive DNS information that we use, Farsight's DNSDB in order to harvest this. They are by far the most complete source that we came across, right? But the point is, of course, the attacker can tamper with the logs. And if no one sees the logs, no one is going to detect that the attacker did something. But he cannot tamper with those other things without cost. He cannot keep changing the IP addresses all the time, right? They will have a structure that they set up, and they're trying to milk it, and trying not to be detected for as long as they can, before they actually have to invest their time, money, or whatever evil resources that they have to move to the next thing. So it helps out pretty well. I think that potentially, I mean, there is a path to try to finding malicious stuff by anomaly detection, but it has to be grounded in somewhere that cannot be easily tampered with anything else. But what about the false positives, right? You were talking so much about false positives and stuff like that. And it's a fact of life, right? You're never going to get everything right, and you might as well just accept that. And if anyone, again, it's like the 100% security thing. You just like walk away if someone starts talking about that. But the feedback that we got is that they were good false positives, whatever that means, right? I don't like false positives at all, but yeah, it could have fooled us. It could have fooled, I mean, people had extensive trouble in actually trying to disprove that this thing was bad, but we figured out it was a misconfiguration on a link online thing on somewhere else, which it was actually pointing such and such. And the cool thing is that this feedback and it's actually improving the model over time for everyone who's potentially using it. Because, of course, there's stuff that we get ridiculously wrong, right? Because everybody does. It's a learning process, literally. But it helps us uncover what are the different features and what are the different things that we should be looking at and adding to the potential models so that they can get stronger, right? And remember, I'm proposing this as triage, right? It's not going to tell you like it's Captain Mustard and with the candlestick and the library, but it's going to tell you, man, you should head to the library right now. Some shit is going to about to happen right there. So it should be enough. I mean, when you're talking about the amount of information that has to be sifted, right? It should be enough to help focus people, right? And help them do a better job. So anyway, I propose a buyer's guide, right? So if people are actually trying to push you something, if people are actually trying to tell you about how awesome this machine learning thing is, right? You should ask them a few questions, right? And I mean, for the ones who have been paying attention, these were exactly the questions that I just answered. But you should try to get a better understanding and get a grasp of what is the ground truth, what should be important. Should this model ever work? Does it make sense what people are doing, right? Before anyone is to move forward. I just don't want people to waste their time. I hate asymmetric information, especially in sales. And I think that if we're not able to choose the tools we're voting with our money, right? That whole shebang. If we're not able to choose the tools that are actually doing the most valuable research, we're going to pretty much stay where we are forever, right? And I don't want that. I don't want to pilot sims anymore. God forbid. Help me out, guys. But anyway, I also propose a game, right? If a vendor comes to you and tells you a bunch of stuff about machine learning, and you ask them the questions, right? And they say, no, I do anomaly detection, but I'm different. I'm not like all those guys you've met before, right? I am very different. I'm not exactly the kind of person that you think I am. I propose a new hashtag called not all algorithms, right? So just hashtag them, and please don't hashtag me, right? Of course you can, just do whatever you want. if you don't agree with what I've said. But the point is, let's try to understand, and let's ask the hard questions. Let's understand what these questions are, and how we can better we can better use machine learning, and we can better evolve as an industry, and hopefully actually get some vacation, right? Like the joke in the beginning. I don't need to lose your jobs, but maybe, I don't know, only working 5 times a week should be good, right? Anyway, just wrapping up, don't take my word for it, right? If you guys want to sign up, help us test, send me an email, whatever. It should be relatively easy to find me, right? We are, it's not just if you want to get a report, if you're interested in some sort of data sharing agreement with the threat intelligence stuff, we are all for that as well. Anyway, just the small plug. And limited capacity, guys, so I'll get to all of you, but, let's move this. Anyway, that's pretty much all I had. Thank you so much. How much do you have time? Anyone want to ask a question? Yes. I'm not sure if I heard the question right. Can you? Oh yeah, okay. How marketability drives the learning techniques. The problem, so the question is, should I use a neural network because the name is more trendy? Is that it? Is that what you're asking? Okay. To be honest, I haven't quite come across that as blatantly, right? But I would not be surprised if we have companies that they come forward saying that they're using deep learning, right? To do, so yeah, we're using deep learning neural networks now because it's the new hotness in machine learning. And deep learning is something that's specifically dangerous because nobody really understands how they work, although people sound like they do. And there's actually a lot of research where you're actually doing this, all this sort of image parsing that they do with deep learning right now. Huh? Yes, the blind spots, exactly. So people don't really, they think that they're actually decomposing the frame. Oh, this is a house. But actually, no, it's some weird points. You can just edit the image, which is visually the same, right? But then the model is completely lost. So if we have, and again, images are complicated, right? But if we don't have a good grasp, a good intuition how the model works, what's going to come out of it, right? I mean, for my stuff, I run a bunch of them. I have a bunch of different algorithms for each day, and whoever wins, wins. Okay, this was the one that had the best performance. That's you're king for the day, right? Let's see what tomorrow brings. And I think that's the way the algorithm. It's just like, at least in my perspective, it's just like crypto. All the primitives are there. Everyone knows the primitive. It's like, you can't, oh my God, nobody must know that I'm using AES. No, it's all about the engineering that you put around it. Are you salting? Are you hashing? What are you doing first? How are you actually building it out? Any more? Yes. Sorry, he was there first.
Yeah, some of my customers would be not too happy about the sending people log files. Although I think they'd be quite happy to get the result back with us. Can we sanitize the log files? Can we change the IP addresses? IP address A is always IP address B.
I have work where I have sanitized some things. So we actually have, I mean, it's one of our internal tools which actually helps sanitize and anonymize a bunch of stuff. It pretty much gets whatever you tell them, whatever you tell it, it's sensitive, and it age max it and encrypts it with a key that only you have. So I can give you back, okay, this is the age mac that I got as a result, and then you go back and you reverse it. The problem is, so the internal IP addresses, I don't care, right? As long as I can tell them apart, that's awesome. But of course, I need the external IP address. Otherwise, there's absolutely nothing that I can do.
See, that's the thing that everybody uses 10 dots, right, for a large enterprise.
Yeah.
We don't care about the 1918 address. It's the global
Well, I didn't understand.
I'm sorry, we don't care about the not internal address, we don't care about the external
Yeah, yeah. So yeah, the work.
server to send to someone.
Yeah.
Then you'll be able to identify the organization.
Yeah, and I've come across this before. Actually, I heard organizations that were like that, and I'm afraid there's not a lot that I can do about that.
Side question, we can also subscribe to the get these.
No, it doesn't work like that. I'm specifically trying to not crowd people with information. I mean, it wouldn't make sense. It would, although I do want to create some sort of API so that you can, okay, let me check this internally here to see what would come out. But the model really shines when it actually has your data to do some comparisons against the actual proportions that it has inside it. And I mean, it's not like I'm providing you a feed with 100,000 different IP addresses that then you have to figure out for yourself how you're going to match this thing internally. I'm actually just telling you, okay, of your logs, these are the guys that you should investigate. And that's pretty much that's the actual spirit of the thing. So we can talk more. I mean, happy to take a card, but it sounds hard. No problem. Please.
Thanks very much. That's a very good presentation.
Thank you.
So, there have been some things that we're checking on the same page about here. Just specifically talk about the classification and the data profile. What algorithms have you seen in
What I?
algorithms? Which algorithms are machine learning algorithms? You talk about the simple one, right?
Oh, you mean? I don't know. There's a bunch of them. I mean. I don't think I'd be able to name one for you. I mean, I can chat. We can try to chat offline, and maybe I can run some names by you to see if it's the same people that you know. But I would be hard pressed to try to endorse any of them or anyone. I specifically avoid saying any names of any companies here, although I made fun of a bunch of them. So it's anyway. That's one of the perks of the job. But thank you. Anyone else? Yeah, there's one there. Anything that you can identify IP addresses or domain names. So think about outbound firewall logs. Think about web proxy logs. IDS logs, yes, but IDS logs make more sense for inbound stuff. I mean, the model works both for outbound threats and inbound threats, right? But we see most mileage out of the outbound stuff. But anyway, it's so stuff like firewall, IDSs, web proxy logs. Web proxy logs are specifically interesting because you can see what was the IP address that the guy visited and also what was the domain name that he accessed. So that gives it, I can actually have multiple models competing to see which one will win. DNS is also very interesting. There's different stuff that we can get from DNS as well. There's a lot of research in DNS. I have a bunch of friends in OpenDNS as well, and they do some cool work around that as well. Huh?
Why do you get more value out of that?
Because it's more actionable. So people first, threat intelligence is more precise on the outbound thing. Because when you think about inbound, people were just publishing like bazillion IP addresses that someday hit some honeypot, right? And the odd chance that one of that guy attacks you, it's probably going to be exploiting a Joomla vulnerability on your IIS server. So it's all about, I mean, if you have to pick your fights, if you have to, if you're running a SOC or something like that, I would rather focus on the outbound stuff than on the inbound stuff. But both models, I mean, they're pretty much the same at heart, so they would work similarly. Am I being kicked out? Guys, sorry, I'm getting kicked out. What you're going to say, you said you were going to do something to me. What was that? You're going to shame me because if I went past, yeah? Okay, I do not want to be shamed. Thank you very much, guys.